In this video, we're going to talk in a little bit more detail about Rutherford's gold foil experiment. If you're having trouble understanding how Rutherford got any useful information out of this, there's a good analogy. Imagine that you have a fence in front of you, okay, but you can't see the fence. Let's say you're blindfolded and you can't see the fence, and you want to know how far apart the pieces of wood are in the fence. In other words, how much of the fence is empty space and how much of it is actually the fence. So what you do is you take a whole bunch of ping pong balls and you throw ping pong balls at the fence. And then you go and you find out how many ping pong balls went through the fence and how many bounced back. And if you find that most of the ping pong balls went through the fence, then you can deduce that most of the fence was empty space. Right? And that's kind of what Rutherford did, except instead of ping pong balls, they used alpha particles, and they found that most of them went through the gold foil, therefore most of the gold foil is empty space. And there's a few other things that we can take from this. Because most alpha particles were not deflected, Rutherford concluded that atom is mostly empty space. Because some particles were reflected, Rutherford concluded there must be a dense solid portion Rutherford called it the nucleus. Okay, so all the mass of an atom is concentrated in this little tiny thing called the nucleus. And the third thing is that because he knew that alpha particles were positive, and as they got deflected, he deduced that they were repelled by the nucleus, which means that the nucleus must have a positive charge. So the nucleus must have a positive charge. Rutherford's model was also called the nuclear model. Because remember, before Rutherford, we had the Raisin-Bun model, and we didn't have this idea of a nucleus. So it's called the nuclear model. Okay, although he was correct in saying that we had a nucleus, the electrons, however, he wasn't sure about, and he sort of imagined the electrons were spread sort of in this cloud around the nucleus. Then Niels Bohr was a Danish scientist who came along and just added to Rutherford's work. And in the next couple videos, I go into a bit more detail about the Bohr model. Okay, but basically Bohr said that the electrons must be found in discrete energy levels, or shells. And so, if you can imagine, we'll say this is the nucleus. Okay, and that's where the protons are and the neutrons are. Bohr said that the electrons are found in these shells or energy levels. And just to make things simple, we can draw them in little circles like this around the nucleus. Okay, they aren't actually circles. The electrons don't actually orbit like the planets orbit the sun, so it's a little bit misleading, but these are the models that we're going to focus on, and they actually are very useful for a lot of things.